So exo means out, and so you might have seen a diagram before that looks like this with the arrows flowing out of the system. That means it has a negative sign. Signs in thermodynamics indicate direction, okay? So this is an exothermic process, and we would say that that feels hot because we are part of the surroundings, and so our hand would feel the leaving heat as being hot. Endothermic means heat is flowing in. That's a positive delta H, and you might have predicted that that diagram would look like that. So when does this happen? When bonds are being formed, energy is released, and that is then an exothermic process. When bonds are being broken, energy is required, and that is an endothermic process. And then the combination of bonds breaking and bonds forming is what determines if the process overall is endothermic or exothermic. Let's look at a couple of common examples. Probably makes sense to you that burning wood is exothermic because it feels hot. Probably also makes sense to you that frying eggs is endothermic because it requires heat. Might make a little less sense to you that the formation of snow is exothermic. We're used to that feeling cold, but the reason that snow feels cold is because it's actually pulling energy from our hand and then it melts, okay? When snow is being formed, it's going from the liquid state to the solid state. When you're going from a higher energy state, like a liquid, to a lower energy state, like the solid, that extra energy must be given off, and therefore that's an exothermic change. Photosynthesis is an endothermic change. That might make a little more sense to you because it requires light in order to occur. Let's look at some graphs of this. So if you have the reactants going to the products and the reactants are at a higher potential energy state than the products, then that is exothermic. That's the classic way to see that on a graph. This is actually the graph that you can expect to see on the AP exam, potential energy diagram, and then this is time. Endothermic, understandably, looks the opposite of that. So here's a more simplified version of the graph, and then this is what you would see on the exam. And so you can actually calculate the delta H here by doing the difference in the reactants and the product. Now let's express it with some reactions. So one way to write it is just to write the word heat in the reaction. So here it's a product, so that makes it exothermic. Here heat is a reactant, and that makes it endothermic. We can also use the word energy. If energy is a product, it's exothermic. If energy is a reactant, it's endothermic. I find that using one of these ways to represent endothermic and exothermic is most useful when you're thinking about Le Chatelier's principle. You can also use the delta H written at the end. In that case, if it's negative, it's exothermic, and if it's positive, it's endothermic.